I noticed last week that the attendance in the mandatory Zoom classes was near perfect, and so I just want to thank you for that, because I'm relying more and more on explaining some things up front while we're all together, and then working from that understanding that we build in that short Zoom class to have you practice and learn some more challenging things. But we talked today in the Zoom about surface area, and how if an edge length of this cube was 2 centimeters, the area of one of the square faces would be 4. And since there are 6 faces making up the surface of that cube, or if I took one and I'm going to make sure I can see myself so I know what you're seeing. If I took one of these cubes and I opened it up to see the net, and I would know that the net is made up of 6 square faces. And so if the area of any one face is 4 centimeters squared, it must be 24 square centimeters for the area of the surface area of the cube. And so you can see that there. I'm not going to spend a lot of time going over that, because I expect we did that in the Zoom class together. The surface area of a solid is the amount of material it would take to cover it. So we'll look at some examples in a minute. If I had 1 cube, 24 square centimeters, 2 cubes, you would need 48 square centimeters, but we talked in the Zoom about if you connected them, now it's not 48 anymore, because 2 of those square faces are no longer on the surface. So you take away that 4 twice, you take 8 away from the 48, and it would be a total of 40. There are 2, 4, 6, 8, 10 square faces on the surface of this, what is now a rectangular prism, when you connect the 2 cubes. Alright, so here's the framework for solving surface area. If we did this one together in the Zoom, I have no way of knowing at this moment, because I'm doing this way before Monday, then you skip forward to the next slide and do one of the practice problems on your own. But if not, please pay close attention to this. This rectangular prism has its dimensions shown. This distance is 30 inches, 15 inches, and the height is 12 inches. And so the way you find surface area is you label the different faces. Here they've labeled them A, B, and C. I've got another face back here that I could also label A, and then there's another face over here we could label C, and there's another B on the bottom. But since they're congruent, we only need to really consider one of them, and then we'll take into account the fact that there are 2 congruent faces with these dimensions when we calculate surface area. So if you sketch face A and put its dimensions, the 30 is easy to see. I want to erase what I just wrote so it doesn't clutter the picture. The 30 is easy to see when I'm looking at this rectangle A, but the other dimension is not easy to see. You have to look around for it. If this is 12, this must be 12. So we draw the face and we put the dimensions on the face. We use the formula for area of that shape. So for a rectangle, base times height, or length times width, and we get 360 for the area of that face. And I personally like to either use subscript notation, so area of face A is 360, or you could label them 1, 2, 3, however you want to label the different faces. Rectangle B, I don't see any dimensions on rectangle B, but I know this distance must be the same as this, so this is 30, and I know this must be the same as this, 15, and so you see it's been sketched here, the 30 by 15 rectangle with an area of 450, so the area of face B is 450. Face C is this face on the side, and its dimensions are clearly labeled, easy to find. It's 12 by 15 rectangle, so an area of 180. And so I would use subscript notation and say area of face C is 180. Up to this point, all we've done is find area of shapes like we've been doing all year. But here's where you start to consider the actual entire solid. You write a surface area formula, and the formula will be different for different solids. Like for this solid, because it's a rectangular prism, I know I have, let me do some highlighting. I know this face A right here. Got a little issue with Microsoft Office. This face has a congruent face over here. So when I'm writing my formula, I know that there are two faces like area A. I also know that B, which is this top face, there's a congruent face down here, so there's two of area B. And this side face, C, there's another side face over here that's congruent, so two area C. Before we do the calculation, let me show you something. If instead I had a triangular prism, like this one, if I call the triangle A, I have two of those. I have two faces like that. But this rectangle, there's no other rectangle like that one. There's two smaller rectangles, but I wouldn't have two of this face. This formula just depends on what polyhedron you're dealing with and how many congruent faces it has. When you substitute into that formula, for this rectangular prism, you get 2 times 360 plus 2 times 450 plus 2 times 180. So that's 720 and 900 and 360. That's 1980. When you go to put the units, it might be tempting to put inches cubed because we're dealing with something that's three-dimensional. But while this rectangular prism is a three-dimensional solid, when we're talking about area, like just for example, the area of face A is two-dimensional. If you open up this cube, the sum of the area of all the faces is two-dimensional. So we're counting up two-dimensional areas, and the sum will also be two-dimensional. It's just the total two-dimensional area on the surface of the figure all added together. And so it's actually inches squared. It's still area, it's still inches squared, still two-dimensional. Try the next one on your own, but before you jump to it, just make sure you label the different faces, calculate the area of each face first, and then write your formula depending on how many congruent faces you have.